Hi, in this video I'm going to talk about rvalue and rvalue in C++, and I'll talk about rvalue reference vs rvalue reference in C++. Then I'll talk about the move semantic in C++. Let's start with rvalue and rvalue. The first definition is an rvalue is an expression E that may appear on the left or on the right hand side of an assignment, whereas an rvalue is an expression that can only appear on the right hand side of an assignment. The second definition, which is the newer one, an rvalue is an expression that refers to a memory location and allows us to take the address of that memory location via the AND operator. An rvalue is an expression that is not an rvalue. So rvalues are temporary objects without names, objects which have no address. So to summarize this, it means that in general, the first definition tells us that the rvalue can be in either side of the assignment operator, while the rvalue is always on the right side of the assignment operator. But this is a very specific definition. So definition number 2 is more general, which indicates that an rvalue is an expression that has a memory location in the memory, and we can retrieve that memory address, while the rvalue is just a temporary object. For example, in this line, and define integer a equal 5. In this line, a is memory address, or it's a variable which has a name and a memory address, so it's a left value, it's an rvalue, while 5 is temporary object in the memory of type integer, which has no memory address, and this is why it's rvalue. And based on the first definition, also you see the rvalue is on the right side of the assignment operator. The second line is similar, integer b equals 6. B is an rvalue and 6 is an rvalue. Here a equal p. We know that both of them are variables, and both of them can be retrieved and memory address. So a and b are rvalues, even though you see p in the right side and of the assignment operation, and this does not contradict with the definition 1, which says an rvalue is an expression E that may appear on the left or on the right. In this case, p is on the right, but it still is an rvalue. 5 equal 2. This operation is not allowed, so if an error will be thrown if you execute this line, because rvalue required as left operand of an assignment. The value on the left side of assignment operator, it must be an rvalue. It can't be a temporary object, so this assignment operation is rejected. We know a is a variable, which is rvalue, and we can retrieve its address, and so that we can create the pointer p, which take the address of variable a. Now, what's the definition for rvalue reference and rvalue reference? In the previous slide we talked about the rvalue and rvalue. Now we are going to talk about rvalue reference, and R value reference. So if T is any type, assume it's integer, string, any type. So T with two and symbols is called an R value reference to T, while T with one and symbol is called an L value reference. Notes: the compiler treat named R value reference as an L value and an unnamed R value reference as an R value. Functions that take an R value reference as parameter treat the parameter as an L value in the body of the function. The compiler treat a named R value reference as an L value. I'll explain this through the example. Let's see what's examples of L value and R value reference, the main function. So integer a, we define a is an L value, so this is an L value reference. So both a and b share are different names for the same location, so they have the same address. It's like alias. B is an alias to a. P++, this operation is allowed, and so after this both p and a, because they have the same memory address, both values will be equal to 2. Now here I'm trying to define an L value reference to 5, but we know 5 is an R value, which is temporarily, so I can't take its address, so this will throw an error, can't bind non-constant L value reference of type integer reference to an R value. But if we add constant to the same line, if we add the constant, it will accept it, because constant to reference, constant to L value reference, it's like a temporary object, and temporary object is an object that you can't, it's constant, you can't change its value. So here it's okay to define this with constant reference, but D it's also cannot be changed. Now this symbol 2 and it's an R value reference. So now we have an R value reference, but even though now the compiler treat I itself as L value, because now I is an R value reference, and according to this notes function treat the compiler treat a named R value reference as an L value and an unnamed R value reference as an R value. So here we have named R value reference, then it's been treated as an L value, so I is an L value, while the whole expression, the 2 and operator symbols with I is an R value reference, and I can do this operation I++, then I value will become 6. Here I have first function takes an L value reference, and if I try to pass an L value to it, the operation is okay, f1 of a, because a is an L value, and the f1 takes an L value reference. If I try to pass f1, this will throw an exception, because 1 is a temporary object, it's an R value, and passing an R value to rvalue reference is not allowed. Here we have f2 takes constant to value reference, and we notice that constant to value reference can accept constants. So f2 of a is accepted. A is an value, and 1 is temporarily object, which is rvalue. So both expression or both calls will be accepted. The last function f3 takes an rvalue reference on its parameter. An rvalue reference can accept temporarily object or r values. For example, f3 of 1 is okay, but it can't accept an value. So to summarize this, value reference is described with this expression with the two and symbols. This is called rvalue reference, and with one symbol it's called value reference. Function overloading using rvalue reference. Here I have a function that take value reference as a parameter, and this is the same function name. The function itself is overloaded using the rvalue reference. In this case here, inside the function, I can change the value v. While if I defined it as constant integer reference, I can't change the value inside the function. So I have benefits from this overloading. As you can see here, I defined a equal 5, and now I can pass to the same function name f value, and I can pass it a temporary value or an r value. And see, for the first one, if a, it will go to the first, it will call the first function, and f of 5, because this is an r value, it will call the second function. Here I'm trying to introduce you to like why we need the r value reference, but before that we have to know what is the problem when copy an object that has a resource. Resource, it means that we have big objects or an array created in the heap. So first of all, this is a simple class person. It has name as private member, and here is the constructor that takes the name and assign it to its member, private member. This is the destructor. This is a copy constructor, and this is assignment operator. In the right side here I have class team. Class team has in its private member the name of the team, and it has lists of person or vector of person represented by a unique pointer to a vector. And this is the constructor of the team. It takes the name of the team in its parameter and vector of strings which represent the name of person. Through this name I'll create person objects, as here as side name equal name, and here I let the unique pointer to create to define, because the unique pointer is null. Now I'm trying to create to make it point to some memory, some object in the memory, and here I am iterating over the vector of names, the vector of string provided, and I using empty back I'm pushing or creating new object of type person. This person has the name string provided in the person list. This is the destructor, and here I have copy constructor that takes another team object, and inside to do the copy constructor I have to use the equal operation. This assignment operation will do copy for every object, every person object, from this vector into this vector, and the same for the assignment operator. Here is function. Here is the main function that uses the class team. First of all, I define team A with the name of the team is A, and it has 3 person: Tom, Sam, and Dan. And here, this is the print messages after creating this vector. But actually we need to focus on the problem with the assignment operator or the copy constructor. So here I define a new team P, and it will be assigned the values of the team A. So as you see here, we are defining a new team, and every person in the team is being copied. So if we have a million person, like every person, every object will be copied into the new team, and this is very expensive operations. So the move constructor, and this is the solution, is to move the move constructor and move assignment operator, which actually take or uses the rvalue reference we defined before. So in addition to the constructor, destructor, and copy constructor of the previous class we saw, class team, we need to define 2 new methods. The first one is move constructor. Move constructor, it takes rvalue reference as a parameter. So this rvalue reference is referring to other object, and here instead of using the assignment operator, I'm calling the move std move function, and this means to transfer the ownership for this pointer, which is personal list that points to the vector. I'll move the ownership from the other object pointer person list to my pointer, which is personal list, and without any copying. It's just it's a kind of moving the ownership of the vector itself. So after that, the other .person list will be empty, and now person list will point to this this list. We just change the pointer value. So if we have a vector of million elements, none of the elements will be copied. It's just the pointer. And as you can see here, the same example. Here we define team A, and as we saw before, team P equal A. This is expensive. It will call the copy constructor, and 3 objects will be copied, or every object in the vector will be copied, while the if we define team C equal move A, the copy constructor will be called, and none of the object will be copied. And as you see here, there is no object is copied. So It's very efficient with comparing to the copy constructor. So this is how I took advantage of the rvalue reference to implement the move constructor when the object has any resource that has big data like the vector of objects, so it's better and more efficient to transfer the ownership of the data instead of copying it. The rule of 5. The rule of 5 is an extent of the rule of 3, which says that if you have to use any of these, if copy constructor, copy assignment operator, or destructor, if you implement one of these, it means that you have to implement 3 of them. So these functions are usually required only when a class is manually managing a dynamically allocated resource, like the one we saw. The unique pointer points to vector, and so all of them must be implemented to manage the resource safely. This is the rule of 3. Now the rule of 5 say also, if that's the case, if you have to implement the 3 of these, also you have to add two methods. The first one is the move constructor, and the second one is move assignment operator. std move, we saw this function while implementing move constructor, but internally what does it do? It's exactly equivalent to static cast to an rvalue reference type. Return value is static cast, and it will remove the references. So it's casting the object into an rvalue reference type. So if we have a function that take an rvalue reference and we want to pass an L value, we can do std move to change it to an r value. Here is an example. Slide. This is the main function. Suppose we have string equal apc and vector of a string named v. It's initially empty. So use pushback constant t-reference overload, which means we will incur the cost of copying constructor. So v.pushback of a string, it means that it will add to the vector a copy of str. So there should be a copy, and str itself, it will not be affected. This is why here, see, after copy str is stay the same, which is apc, while here use the rvalue reference pushback overload, which means no string will be copied. Instead, the contents of string str will be moved into the vector. This is the less expensive, but also means str might now be empty. So here we are in pushback, we are using std move of a string, which means move the ownership of this or transfer this ownership into the vector, and it's more efficient, more faster than a pushback without std move. The only thing here, after this operation, the str loses its ownership to the object abc, so the string will be empty after that, as you can see here. And because we pushed to the vector again, so the vector has 2 strings now. Here is another example of how to use the std move. We define a unique pointer which points to an object of type integer, and the value of the managed object is 5. Here is unique pointer 2. I want to use the you can't use the equal or the assignment operator, because two unique pointer can't point to the same managed object. In that case, to transfer the ownership from pointer 1 to pointer 2, I use std move. In that case, unique pointer 2 will point to this object, and unique pointer 1 it will be empty or null pointer after that. So if I print the value of unique pointer 2, it's 5, and if I want to check if the unique pointer 1 is null, it's indeed the null pointer. This function take an rvalue reference as a parameter, and here I defined a as an L value. So FLA, because the function take R value reference, passing an L value will be rejected. So this will throw an error, can't bind R value reference of type R value reference to L value of type integer. So what is the solution? The solution is to use std move of a. So it will cast a into a temporary object or an R value object, and in that case integer is primitive type, so just copy happens and stay 5. So as we said, std move, it might make the original object as empty in case it's a string or object, but here this is primitive data type, which is integer. So std move is it's just do a copy, and the value of a will remain the same. F5 is also possible because 5 is an R value. Here is another example. We saw previously how to use the std move inside the move constructor. This is how I define move constructor, and here I just use std move to assign the arg.member to member, and the same thing with the assignment operator. Move semantic. In summary, move semantic allows an object under certain conditions to take ownership of some other object's external resources. This is required for two reasons: turning expensive copies into cheap move. As we saw in the example for team, we don't have to copy all the vector, we just transfer the ownership. Second of all, implementing safe move only types, that is types for which copying does not make sense but moving does. Example, unique pointer. As we know, the unique two unique pointers can't point to the same memory location. In that case, if I want to assign or transfer the object to another unique pointer, I can do the assignment operator. So I have to do to use std move. In that case, the ownership will be transferred to the new pointer. Thank you for watching.